Good morning, good afternoon, good evening. I am the Oracle of Chinem Kutu, and this channel is all about the revision of mathematics at all levels, from ordinary level, AS level, and grade 12, advanced level, even up to university. We are going to be doing revision of questions that have appeared in past examination papers at all these levels. And we would encourage communication where you would send me stuff, you comment, and you can send me stuff directly on my WhatsApp platform. The objective of this channel is to encourage students to do revision of mathematics. The classroom setup, the teacher teaches from a given set of textbook, and he gives a few examples. The students go home, they are given a number of questions as the homework. They do the questions, and they are focused on doing well in those questions, and at most they lose the ability to understand. And soon after they've done their homework and they've passed that homework with flying colors, they don't do practice. And for you to understand mathematics, practice is of the essence. Yes, you can study mathematics, you can write notes, you can read textbooks, but if you cannot execute the principles and concepts that we have grasped to answer questions, then it remains a challenge. So you will ask me what is different about this channel, or what is it that I'm going to add value to your learning of mathematics. I will go straight to answering questions, and in the process of answering those questions, I'm going to be teaching. I will state concepts, and you will see how that concept is applied to a particular question. And that will help you develop critical thinking. It will help you develop analytical thinking. It will help you develop the killer instincts of a mathematician. A person who is mathematically oriented, once they see a question, they dive and go for the kill. So a particular given question has got a number of applications that you would need to put into effect in order to get the required solution. So I will name each session by the application that is being used in that question. And if it is the first, let's say it's an application of calculus and it's differentiation 1, we will name that session application of calculus differentiation 1. Application of calculus 1, differentiation 1. And then if we are going to be forced to cut the videos so that they can be comfortably uploaded on YouTube, we will have to divide those videos into parts. So it would be application of calculus 1, differentiation 1, part 1, application of calculus 1, differentiation 1, part 2, in that order. So that will help us to make sure that the videos are not too long, and also that the students can follow through and see that the question started from this point and it ended at this point, and this is our solution. So we have had the sessions that we uploaded on the channel already, but because we were using a weaker device in terms of zooming in on the question and on the board, the visibility was poor, so we decided to get a better device, and we are going to give it a try. And if this better device will allow us to zoom in on the board and for the students to be able to follow what I'm writing and what I'm saying, then we will remove the videos that we've already uploaded and upload new ones. And we will remake the ones that we have already made so that the students can see clearly what I'm doing and follow through. so that you can be able to follow through from what I say, and also you will be able to follow through from what I write on the board. So today we have got 2 questions, question 1 and question 2. We will start with question 1, which appeared in the 2012 for higher grade paper 1. It was question 6.3. And that question at the top there says, the line y is equal to 4x minus 3 is a tangent to the curve gx is equal to minus 2ax cubed minus bx at x is equal to 1. Determine the values of a and b. So immediately you are told that this is a line. You start thinking in terms of the general equation of the line is y is equal to mx plus c, where m is the gradient of the line and c is the y-intercept, which is the value of y when x is equal to 0. So in this case, our value of y when x is equal to 0 is minus 3, and the gradient of the line is, of course, 4. So gx is actually a cubic function. And as a cubic function, you want to find out the value of a and b. Immediately you are asked that you know you have got 2 unknowns, which are a and b. And if you have got 2 unknowns, you need 2 equations in those 2 unknowns in order to be able to solve for those 2 unknowns. So our topic would be, this is an application of calculus one, and we will be applying differentiation and it's basic differentiation, it's not advanced at all. So when we cut the videos, we'll put part 1, part 2, depending on what we'll be doing. So having been given the line and the curve, the point of tangency, which is x is equal to 1, is basically the point at which the line touches the curve. So the line and the curve at the point where they touch each other are both, their equations are both satisfied by x is equal to 1. So for the line, y is equal to 4x minus 3. We know that the gradient of this line is 4, and at x is equal to 1, y is equal to 4 times 1 minus 3, which is equal to 4 minus 3, and that is equal to 1. Then for the curve, we have gx is equal to minus 2ax to the power 3 minus bx squared. At x is equal to 1, we have gx equals to y equals to minus 2a1 to the power 3 minus b1 to the power 2, which is equal to minus 2a minus b. Therefore, we can say we have minus 2a minus b is equal to 1, because at that point, using the equation of the line, which is the point x is equal to 1, we know that the value of y is equal to 1. So if you multiply through by minus 1, we will have 2a plus b is equal to minus 1, and this is your equation 1. So already we have used the knowledge that we have about the point of tangency and used the equation of the line and the equation of the curve in order to get our first equation in the two unknowns, 2a plus b is equal to minus 1. So we need something else to help us get our second equation. And that something else comes from our knowledge of the fact that at the point of tangency, the gradient of the curve and the gradient of the line are equal. In other words, at the point where the line touches the curve, the gradient of the line is the gradient of the curve. So this is a cubic function. To get its gradient, we differentiate with respect to x. So we say here, gradient of the curve equals to dy dx equals to, and we differentiate with respect to x, that would give us minus 6a x squared minus 2bx. And at x is equal to 1, dy dx equals to minus 6a bracket 1 to the power 2 minus 2b times 1. And that is equal to minus 6a minus 2b. And this gradient of the curve is actually equal to 4, which is the gradient of the line, which we said that the general equation of the line is y is equal to mx plus c, and m is the gradient of the line, and here our m is equal to 4. So therefore we have minus 6a minus 2b is equal to 4. Divide throughout by 2, or divide throughout by minus 2, you get 3a plus b is equal to minus 2. And this gives you your second equation. So now we bring the two equations together. We now have two equations in two unknowns. And we will solve the two equations in two unknowns simultaneously in order for us to get the value of A or B. So we have the 3a plus b is equal to minus 2, and 2a plus b is equal to minus 1. This is 2, this is 1. So what we are going to do is to say equation 2 minus equation 1, which would give us A is equal to minus 1. and then we use minus 1 into equation 1. Substitute A is equal to minus 1 into 1. We get 2 bracket minus 1 plus B is equal to minus 1. That would give us minus 2 plus B is equal to minus 1, and B is equal to 2 minus 1, and B is equal to 1. So we are done, and basically this means that Gx is equal to our A is minus 1, so minus 1 times minus 2 gives us 2x to the power 3, and our B is 1, so it is 2x to the power 3 minus x squared, and that's the cubic function that we have. So this question was the 8 marks. So it was not difficult, but not too simple. And you have to realize that when you are dealing with the Matric questions, they are set at about 3 different levels. You have the very simple ones, and then you have the medium, and then you have got the difficult ones, and then you have got the very difficult ones, which is level 4 question, and those require you to think out of the box. So if you are given a simple question at the beginning, and they start to get hard as you go along the questions, don't panic. Just know that you have different levels of question within the same paper. Once you panic because you have been given a very difficult question, you start panicking and you fail even the things that you are supposed to be able to tackle. So our first question is done. Good morning, good afternoon, good evening, and welcome back to part 2 of the application of Calculus 2 differentiation. We are now going to be answering question 7.1.3 and question 7.1.4, and in keeping with our naming convention, this is the application of Calculus 2 differentiation part 2. So we have already shown that A is equal to minus 1 and B is equal to 3 as required. Therefore, the cubic function fx is equal to y is equal to, our A is minus 1, so this is minus x cubed, and our B is equal to 3 plus 3x plus 2. And we are required by question 7.1.3 to determine the coordinates of B at turning point of F. that is B there, and when they say it's a turning point, you can see it is a turning point. And at the turning point, the gradient at that turning point is 0. And for us to get the gradient of B, given the cubic function, we differentiate the cubic function in order to get the gradient. That is where the application of differentiation comes into play in this question. So, let us differentiate our cubic function with respect to x. We have dy dx is equal to, differentiation is basically multiply by the power and reduce the power by 1. So our dy dx is equal to minus 3x squared plus 3, and our constant goes to 0. So this is equal to gradient of fx at any point on the function, because that will be determined by the value of x at that point. So at point B, we know that the gradient is 0 because it is a turning point. Therefore, we have 3 minus 3x squared plus 3 is equal to 0. And we have divide both sides by minus 3. We get x squared minus 1 is equal to 0. And therefore, by factorizing the difference of two squares, which is x squared minus 1, we have x minus 1 multiplied by x plus 1 is equal to 0. Therefore, x is equal to 1 or x is equal to minus 1. And looking at where B is, x cannot be minus 1. So therefore, the x coordinate of B is equal to 1. So then, using the cubic function, with x equals to 1, we have y equals to minus bracket 1 to the power 3. Notice that the minus does not include the 1. It's a minus 1 which stands alone, and the x which stands alone. So our x is 1. Don't put the minus in the bracket, and if you have a square there, you might end up with the wrong result. So it's a minus bracket 1 to the power 3 plus 3 bracket 1 plus 2. That gives us y is equal to minus 1 plus 3 plus 2, which is equal to 4. And therefore, the coordinates of B are x is 1, and y is 4, and that's the solution to that question. And that question was 4 marks. Not very difficult, but fairly difficult. The next question is perhaps more challenging, and it says 7.1.4, show that AB is parallel to the x-axis. So in other words, we need to find the coordinates of A, and if the y coordinate of A is equal to 4, then we know that the line that joins A to B is indeed parallel to the x-axis, because the gradient of that line will be 0 and the gradient of the x-axis is 0. So for us to find the coordinates of A, we notice that at point A, it is a point of intersection of the cubic function and the line. So in other words, the coordinates of A satisfies both the line and the cubic function. So 7.1.4, we have cubic function y is equal to minus x cubed plus 3x plus 2, and our line y is equal to minus x plus 2. If this is your equation 1, this is your equation 2. Then at A, we have equation 1 is equal to equation 2, and therefore we have minus x cubed plus 3x plus 2 is equal to minus x plus 2. Then let's take everything to the right hand side. So we will have x cubed minus 3x minus x plus 2 minus 2 is equal to 0. And then we have x cubed minus 4x plus 2 minus 2 is 0, is equal to 0. So if you notice here, we have x cubed minus 4x is equal to 0. And at the top here, we had the 3x minus 3x squared plus 3 is equal to 0. And we divided throughout by 3 minus 3 in order to get x squared minus 1. Here you can't divide by x, because if you do that, you will lose a solution. X is equal to 0 is a solution to this equation. So if you divide by x, you will lose that solution. In order to avoid that, we factorize first x out, and we have x squared minus 4x is equal to 0. And we factorize further, so we have x bracket, this is a difference of 2 squares, x squared minus 4x, so we have x minus 2 bracket bracket x plus 2, all is equal to 0, and therefore we have x is equal to 0, or x is equal to 2, or x is equal to minus 2. If we look at the point A, where it is located here on the graph, we can see that x cannot be 0 there, and x cannot be 2 there, so therefore x is minus 2. Therefore, the x coordinate of A is minus 2, and using this with equation 2, we have y is equal to minus bracket minus 2 plus 2, which is equal to 2 plus 2 and equals to 4. Therefore, the coordinates of A are x is minus 2 and y is 4. So in other words, if you draw a line from A to B, it passes through 4 and gets to B, and you can further show that the gradient of AB equals 2 if we take the y coordinates of point B and point A. If we start with the point A, we have 4 minus 4, and the x coordinate of point A is minus 2 minus 1 for B, which is equal to 0 over minus 3, and this is equal to 0. So in other words, the gradient of AB is 0. So we can say the gradient of AB equals to 0, and therefore AB is indeed parallel to the x-axis, as we have been required to show. So part 2 is done. We have answered question 7.1.3 and 7.1.4, and those are 9 marks. Probably the 2 of them were the most challenging. And then in the next part 3, we will be looking at question 7.1.5 and 7.1.6. Thank you.